Logic for homeschoolers, or for anyone really, a very brief introduction to basic logic, lesson 5 on the branches of logic, and you will not understand much of lesson 5 if you do not do lesson 4. There are 4 good things we want for our arguments. We want them to be valid, sound, strong, and cogent, or at any rate, we want them to be as many of those things as they can be, or as is appropriate. We want them to be valid and sound, or strong and cogent. They can't be all 4. An argument can be valid, invalid, valid and sound, or valid and unsound, or invalid, unsound, strong, cogent, or invalid, unsound, strong, uncogent, or invalid, unsound, weak, uncogent, and go back and watch the last video if you don't know what all these words mean. As far as logic is concerned, validity and strength are the really important ones. Now, the difference between an argument that's valid and sound and an argument that's valid and unsound is just whether the premises are true. The difference between a strong argument that's cogent and a strong argument that's uncogent is just whether the premises are true. But as far as logic is concerned, we're not so much interested in cogency and soundness as such. We're interested in validity and strength because we don't really care all that much about whether the premises are true in logic. As far as logic is concerned, that's not really our job. The work of logic is to determine whether the premises, if true, would make their conclusion probable, certain, or neither. Are the premises true? Well, that's what everything else you study is for. There are some different types of arguments. Sometimes an argument is meant to have premises that guarantee their conclusion, but sometimes all an argument is even aiming for is good probability. And we can classify our arguments by those intentions with which they are used. A deductive argument is an argument in which the premises are intended to guarantee the conclusion. An argument which, in other words, is meant to be valid. An inductive argument is an argument in which the premises are intended to make the conclusion probable, an argument which is meant to be strong. And we can define different kinds of reasoning in a similar way. Deductive reasoning is trying to make arguments whose premises guarantee their conclusion, or trying to make valid arguments. Inductive reasoning is trying to make arguments whose premises make their conclusion probable, or trying to make strong arguments. Now, these definitions define deductive and inductive arguments in reasoning by the intentions or the goals of whoever is making the arguments. You might find other sources defining these terms or similar terms by whether the arguments succeed in those goals. I think defining the terms and the way we're doing it here makes the most sense. If we defined them according to whether they succeed, we would just be reusing the definitions of validity and strength with new names. In other words, if we said that a deductive argument is one where the premises succeed in guaranteeing the conclusion rather than just one where they're meant to guarantee the conclusion, or the deductive reasoning is making premises that using arguments whose premises guarantee the conclusion rather than trying to use arguments whose premises guarantee the conclusion, then we're just making new terms without any need. We're just describing valid arguments here. We might as well just say deductive argument means the same thing as valid argument, and deductive reasoning means the same thing as making valid arguments, and what's the point of even using these terms? But I think there is a point using terms like deductive and inductive arguments and deductive and inductive reasoning, and to make the distinction between, to make these definitions based on the intention of the arguments, the intention of the reasoning. Deductive arguments are ones that are meant to guarantee the conclusion. Inductive are those that are meant to have premises that guarantee the conclusion. Deductive reasoning is reasoning that's meant to produce arguments whose premises guarantee the conclusion. All right. Anyway, let's move on. Those are the working definitions I propose to use. There are 2 main branches of logic. Logic has tools and strategies for testing deductive arguments for validity and testing inductive arguments for strength. And those are the 2 branches of logic. Deductive logic is the branch of logic that's concerned with tests for validity and invalidity, and inductive logic is the branch of logic concerned with tests for strength and weakness. Now, normally we use deductive logic on deductive arguments and inductive logic on inductive arguments. Inductive reasoning calls for, what did I say? Inductive reasoning calls for inductive logic. Deductive reasoning calls for deductive logic. But be prepared to use inductive logic on deductive arguments. Deductive reasoning calls for deductive logic. But sometimes when deductive logic has done its job, we find that an argument is in fact invalid, but that doesn't mean we can just write it off as useless. It might be a decent probabilistic argument. So then you have to do inductive reasoning as another phase of the work of evaluating an argument. Be prepared to use inductive logic on deductive arguments if we use the tools of deductive logic to determine that an argument meant to be valid is actually not valid. We still use inductive logic to see if it's a strong argument. Well, ideally, if we have time, but be prepared to do it. Once in a while, an argument meant to be strong, an argument that's just trying to provide good probability and not guarantee its conclusion, might be better than it was intended and end up being valid. So it is possible to also use deductive logic on inductive arguments once in a while, but that's somewhat unusual. Now, deductive logic has two basic systems, but first we must define another vocabulary word. A term is a noun or a noun phrase denoting a category of some sort. Guinea pigs is a term. It denotes the category of guinea pigs. Pizzas is a term denoting the category of pizzas. Teacups is a term denoting teacups. Teacups whose contents are still too hot to drink is a term denoting teacups with that characteristic. Remember that deductive reasoning means reasoning that tries to make arguments valid. And there's several varieties of deductive logic, and we're interested in the two basic ones. These are the only two we care about in this class. And they are categorical reasoning and propositional reasoning. Categorical reasoning is reasoning that tries to make a valid argument by means of relationships among terms in an argument. And then propositional reasoning is deductive reasoning that tries to make a valid argument by means of the relationships of the atomic propositions in an argument. And I realize I have not defined atomic proposition in this video, but I did in an earlier video. So once again, go back and watch the earlier videos if you don't know what I'm talking about. Nevertheless, I'll give you briefly an oral definition. An atomic proposition, also called a simple proposition, is a proposition that does not contain any other propositions as its component. It's not made of any other proposition. So if I say the teacup is hot, that is an atomic proposition. If I say it's not the case that the teacup is hot, that's not an atomic proposition because it's made of the proposition, the simpler proposition, the teacup is hot. Denials of propositions, negations of propositions are not atomic. They're made of the propositions they're negating. More simple example, the teacup is hot is an atomic proposition. The tea kettle is hot is an atomic proposition. The teacup is hot and the tea kettle is hot is a proposition made of those other two. Now, a lot of this stuff is easier to understand with simple examples. So let's do simple examples. Here's some simple categorical reasoning. No seekers of wisdom are actually wise. All true philosophers are seekers of wisdom. So no true philosophers are actually wise. What an egregious typo. Let's go over that one again. No seekers of wisdom are actually wise. All true philosophers are seekers of wisdom. So no true philosophers are actually wise. That is a categorical argument. Here's some propositional reasoning. If ifs and buts were candies and nuts, we'd all have a very Merry Christmas. Some people do not have a very Merry Christmas last year. Therefore, it's not the case that ifs and buts are candies and nuts. All arguments use patterns of reasoning. Deductive logic does all of its work by studying the patterns. So we have to look at the parts of an argument to see how they're connected. And the best way to do this is usually to break down the arguments into their smaller parts and to see how they are connected. And this means, this will show the argument's pattern. Break an argument down into its smaller parts and see how they're all connected. That shows the argument's pattern. Now, eventually we learn how to do this in more detail. Maybe we won't in the Logic for Homeschoolers playlist, but it's in the longer Lessons in Logic playlist. And who knows, maybe I'll do another much more detailed Logic for Homeschoolers playlist someday after I finish writing the whole Logic textbook that we're working with here, that I'm writing for my own kids. For now, here are the patterns of the arguments we just looked at. Let's copy and paste them so we can keep track of things. No seekers of wisdom are actually wise. All true philosophers are seekers of wisdom, so no true philosophers are actually wise. That argument has the pattern no y are z, all x or y, so no x or y. We're outside of the USA. No y or z, all x or y, so no x or z. And then the argument, if ifs and buts were candies and nuts, we'd all have a very Merry Christmas. Some people did not. However, last year I have a very Merry Christmas, therefore. It's not the case that ifs and buts are candies and nuts. If X, then Y, not Y, so not X. What a hideous typo that was. If X, then Y, not Y, so not X. That's the pattern of this argument. Notice that we break down arguments using categorical reasoning into their terms, but we break down arguments using propositional reasoning into their atomic statements. And that brings us to our next vocabulary terms. Categorical logic is the branch of logic, the branch of deductive logic, or the system of deductive logic, whose basic components are terms denoting categories. Or categorical logic is the study of arguments by breaking them down into their terms. Or categorical logic is the study of those argument patterns that we find when we break down arguments according to their terms. And then proposition logic or statement logic is the study of those arguments we get when we break. Now, proposition logic or statement logic is the study of those argument patterns we find when we break down arguments according to their atomic propositions. Or the system of deductive logic whose basic components are little propositions or simple propositions or atomic propositions, propositions that can't be broken down into smaller propositions. Or the study of arguments by breaking them down into their smallest statements. Now, we hang on, I didn't mention this other part that's typed here. These are two major branches of logic, categorical and propositional logic, or proposition logic, or statement logic. There are other names used for these branches of logic, like Aristotelian logic, or Aristotelian system of logic, or term logic, or classical logic, basically because in the old days, categorical logic was more prominent in the study of logic. And so those are the names for categorical logic. Proposition logic is also called modern logic because it's been more emphasized in modern times. I think I've also heard it called other names. Never mind the other names. I've given you enough names. We can't use categorical logic on just any argument. We can't use statement logic on just any argument. Categorical logic works well in arguments using categorical reasoning, and proposition logic works well in arguments using propositional reasoning. Doing this with categorical logic, if ifs and buts are candies and nuts, we'd all have a very Merry Christmas. Some people did not last year, therefore, ifs and buts are not all candies and nuts. You can't use categorical logic to evaluate that argument for validity. You'll fail. You'll think it's invalid. If you, however, try to use statement logic on this one, no seekers of wisdom are actually wise. All true philosophers are seekers of wisdom, so no true philosophers are actually wise. That's a valid argument, but you'll think it's invalid if you try to analyze it using statement logic, because those are all atomic statements. You'll end up saying X, Y, Z, statement, therefore statement. Not a valid argument form, but that's because you didn't go into enough detail looking at the argument form. If you study this using categorical logic, you can go into enough detail because this one's using categorical reasoning. There is a more advanced system of logic that breaks arguments down into terms and categories at the same time, and that's the best stuff, except it takes more work, and I don't even enjoy it as much. Maybe I haven't done enough work with it. Maybe I'd enjoy it more. Just know for now that it exists, and it's called predicate logic. And it would be a more advanced system of deductive logic, and it could be used, I think, in theory on basically any argument. Well, let's leave out modal reasoning and modal logic, but at any rate, predicate logic could be used on both this categorical reasoning argument we looked at here about seekers of wisdom and philosophers, and the one about Christmas and ifs and buts and candies or nuts. That's using propositional reasoning. So those are the main branches of logic. Logic is either deductive or inductive. One studying inductive reasoning, one studying deductive reasoning. And clearly I'm going to have to do something about my Zoom controls here. And here we are. Logic is either deductive or inductive, and deductive logic has proposition logic and categorical logic for its main branches, and predicate logic for a more advanced system that combines the tools of proposition logic with the tools of categorical logic. Predicate logic is the best in that respect, and don't expect me to teach you anything about it anytime soon. Now, what are we going to study in this course? Well, in this course, we're interested in some of the basics of inductive, some of the basics of propositional, and some of the basics of categorical logic, and that's all. Most of this course will be spent in learning strategies for completing the steps in the following flowchart, which are highlighted in blue. Because in this class, we're interested in evaluating and categorizing arguments according to whether their premises render their conclusion probable or certain or neither. And just a moment, I better do something else with my screen controls here. And here we are. This is an illustration of the process we should generally follow in evaluating and categorizing arguments. And this is the sort of thing you should be doing ideally with the rest of your life. How much of it are you going to learn how to do in this course? Mostly the box is highlighted in blue. First, identify the premises and conclusion of an argument. Next, find out if it's possible for the premises to be true and the conclusion false at the same time. That's a huge priority in this course. If it's not possible, then the argument's valid. And then if the premises are true, it's sound. If they're untrue, then the argument's unsound. If it is possible for the premises to be true and the conclusion false at the same time, the argument's invalid and unsound, but it might still be a good probabilistic argument. So next blue box, do its premises if true make the conclusion more than 50% probable? If not, the argument's weak as well as uncogent. If yes, the argument's strong. And to evaluate the argument, you still have to ask another question. Are the premises true? If not, it's uncogent. If yes, it's cogent. Oh, also, if it's a sound argument, its conclusion is definitely true, no exceptions. If it's a cogent argument, its conclusion is probably true, no guarantees. And that is all. And thank you for watching lesson 6 next time on Enthymemes.